So let's talk about quantitative variables. I see a lot of people, even in graduate school, get confused and mix up continuous versus discrete variables. These are both ways of describing a distribution of numbers, and the reason why they can confuse people is because they both describe integers in a range. So they both describe a number between two other numbers. So what sets them apart from each other? A continuous variable, when I see continuous, I think infinite. Can't spell apparently. This can take on any value in a range of values. So it can take on any value in a range of values. And we can even break that down further and say that in a range of values means between two numbers. So what's a good example of this? A good example of a continuous variable might be weight class. So I don't know anything about wrestling. I'm sorry if you're a wrestling nerd and I'm totally butchering this. But let's say you're a wrestler and you're needing to like weigh in before the fight or whatever, right? And you have to prove that you're still in the correct weight class. So you have to weigh between 150 and 200 pounds. Now, your coach didn't tell you you have to weigh 150, 151, 152, 153, 154, all the way to 200. They didn't give you that option. They're saying you can weigh literally anything between 150 and 200 pounds. Let's say you had this like crazy insane scale that went out to 10 decimal places. You could weigh 155.253456789, whatever. It doesn't matter as long as it's between 150 and 200. A good way to think about continuous variables is, if it would take you forever to sit there and write out the entire possible data set, that's a good way to think of a continuous variable. Another example that we saw even in an exercise that we did before with our t-test assumptions was the difference between test scores. So that they could range between -20 and +20. But let's say like you had partial credit on that test, or we weren't expecting one to be, pre-test or post-test to be bigger than the other one. So it could take on literally any value between -20 and +20. It doesn't matter as long as it's in that range. That's an example of a continuous variable. So what is a discrete variable? When you see discrete, I think finite. He's limited. So he cannot take on any value in a range. Any value in a range. He's limited in what he can take on. So a good example of a discrete variable would be like if you're leaving a review for a restaurant. So you're leaving like a 1 to 5 star review, right? So you have to leave a 1, a 2, 3, 4, or 5 star review. Why is this yelling at me? Whatever. You can't leave a 1.7 star review, right? It has to be one of those options. Another example might be flipping a coin and counting the tails you land on. So if you flip a coin, X amount of times or whatever, you have to count. You can either have like 1, 2, or 3 tails, right? You can't have 2.5 tails. That doesn't make any sense. That's physically impossible unless you're like in the movie Inception and it's just spinning forever, but that's not relevant to statistics. So it's limited. It's finite. That's a discrete variable. So moving on, whenever I see interval or ratio, or I'm sorry, yeah, interval and ratio, I think of a thermometer. That's just like a good visual representation. SPSS calls both of these, interval and ratio, it calls both of them scale, which is another way to think about it. It'll show you like a little ruler next to your interval and ratio, which is a nice way. But I think of a thermometer, the mercury thermometers with the scores on the side that are equally distanced. So I'm just gonna write thermometer or scale. And an interval or ratio, as you might have already guessed, there's a measurable difference between integers. And we know what that difference is. And we know the difference is consistent. So we know this for both. This applies to both interval and ratio. The big difference with interval measurements is that the 0 is arbitrary. a good example of an interval measurement might be temperature. So going back to that, thermometer example here, temperature, we know that the difference between 20 and 40 degrees is 20 degrees, and that's the same 20 degrees that is the difference between 40 and 80 degrees, right? What this means is that 0 in this case does not mean an absence of temperature. 0 is arbitrary in this case. 0 does not literally mean that there's nothing. So that's the big differentiator between interval and ratio, because in ratio data, your 0 is not arbitrary. Your 0 is literal. So I don't know if there's a more mathematical way to say that, but your 0 means something. An example here would be age. So let's get this to stop highlighting for me here. Hello. So an example would be age. So like if your 0 is literal in this sense, so let's say we're talking about like a baby, right? So he would be like 0 years, 6 months. So in this case, 0 means something. Another really good example of a ratio interval is, let's say, money. So if you have $0, you literally have no money, right? So I hope that makes sense. But this is just a quick breakdown of some of the variables that you'll come across. In SPSS, you're either going to come across nominal, ordinal, or scale. So you'll need to know nominal, ordinal, and then your ratio and interval are both considered scales in SPSS. That's just what SPSS labels them. So next we're going to start diving into working within SPSS and transferring our data from Excel over to that computing software.